Hey guys, tonight we are going to do something a little different. We're going to travel, not with a plane or a train, but with our minds. We're stepping back in time, slowing everything down to a pace that feels almost alien to our modern world. We're going to immerse ourselves in a slow, meticulous, almost meditative process of creating silk in ancient China, from a single, tiny egg to a bolt of shimmering fabric. Think of it as a historical ASMR session, but with the slight, lingering knowledge that if you were actually there, you might accidentally ruin an entire year's worth of a family's income with one clumsy move. No pressure. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, drop me a comment down below. Let me know what city you're listening from and what time it is for you. It's always fascinating to see where we're all connecting from. Now, dim the lights. Maybe turn on a fan for that soft background hum. And let's ease into tonight's journey together. The first thing you notice is the quiet, not the absence of sound. But a different kind of soundscape. The world outside your window is painted in soft, pre-minus dawn grays, and the air carries a chill that smells of damp earth and distant wood smoke. You swing your legs off the hard sleeping platform, your feet finding the cool, packed minus earth floor. The clothes you pull on are simple, coarse minus spun hem, practical and familiar. There's no frantic rush, no blaring alarm, just the gentle, internal clock of a life lived by the sun and the seasons. You are, for tonight, a resident of a small, unremarkable village nestled somewhere in the fertile plains of ancient China, perhaps near the Yellow River, and your life, your family's prosperity, and one of your civilization's greatest secrets, all revolve around a creature no bigger than your thumb. You step outside, the air is crisp. A lone rooster crows somewhere in the village, its call echoing in the misty valley. You grab a woven bamboo basket and your footsteps make a soft, crunching sound on the dirt path that leads away from your simple home. The path takes you towards a place that is both a farm and a shrine, the mulberry grove. The trees are not majestic and towering, but intentionally kept low, pruned and tended with a devotion that borders on worship. Their leaves, a vibrant, perfect green, are the beginning and the end of everything. This knowledge, this entire way of life, is a sacred. It's a technology guarded more fiercely than bronze casting or iron forging. For centuries, the method of transforming a worm's cocoon into shimmering thread is a mystery to the outside world, a source of immense wealth and power for the empire. And the keepers of that secret are not generals or ministers, but people like you, specifically the women in your household. This craft, this art of sericult, is almost exclusively women's work. The knowledge is passed down not in scrolls or edicts, but from mother to daughter, in quiet instructions and shared movements. Your hands, though young, are already learning the practiced, gentle touch required. You know the exact shade of green a mulberry leaf must be to be considered perfect for feeding. You know the subtle signs of disease in a tree, the pests to look for, the way to harvest the leaves without harming the branch. It is a legacy whispered through generations. As you begin to pluck the tenderest leaves, your mind might wander to the origin story everyone knows, the tale of Lazy You, the wife of the mythical Yellow Emperor, sitting under a mulberry tree, sipping tea. As the legend goes, a cocoon accidentally dropped from a branch into her hot cup. When she fished it out, the sticky, fibrous ball began to unravel into a single, impossibly long, and beautiful thread. She was captivated. She studied the worm that made it, learned to cultivate them, and even invented the first loom to weave the thread into cloth. It's a neat, tidy origin story, did for an impress. But even back then, in your quiet, intuitive world, you might sense that reality is often messier than legend. Historians today certainly do. While the story of Lazy You is a cornerstone of Chinese culture, the archaeological record tells a more gradual, perhaps more fascinating story. Scholars are still in a lively debate over the exact timeline. Some point to a cut silkworm cocoon found at a Neolithic site in Shaanxi province, dating back over 4,000 years. Others reference ancient bone needles, ivory cups carved with silk moth designs, and fragments of woven textiles that push the timeline back even further. They argue that the discovery was likely not a single eureka moment, but a slow process of observation and experimentation over centuries. Perhaps someone noticed the strong, fibrous nests of wild silkworms and first used them as simple filling or wadding, before someone else, generations later, figured out how to unravel them. The truth of that very first discovery is a thread that has been lost to time. But here, in this grove, a legacy of that discovery is your entire world. The sun is now beginning to crest the hills, and your basket is getting heavy with fresh, perfect leaves. The first task of the day is almost complete. You walk back along the same path, your balance slightly adjusted to the weight of the full basket against your hip. The sun is higher now, casting long, gentle shadows that stretch from the trees and the low slung roofs of the village houses. The world is waking up, but your most crucial morning chore is already done. These leaves in your basket are more precious than grain. Grain fills the belly, but these leaves weave futures. They are the currency of status, the raw material of beauty, and the foundation of your family being. And they come from a tree that is treated with a respect that borders on reverence. The mulberry grove is not a forest. A wild forest is chaotic, a beautiful tangle of competition. Your grove is a testament to order and control. The trees are planted in neat rows, their trunks gnarled and ancient looking, but their branches are kept deliberately low and youthful. They are pollinated and pruned with an expert's hand each year after the last silkworm season. This isn't done out of cruelty to the tree. It's a symbiotic art. By cutting them back, you encourage the explosive growth of fresh, tender shoots in the spring, and keeping them low, at a height you can easily reach, means that every precious leaf is accessible. It is a landscape shaped by human hands for a single, specific purpose. You know, with a certainty as deep as the marrow in your bones, that only these leaves will do. You couldn't feed your precious silkworms oak leaves, or elm, or willow. They would turn away, starve, and die. The silkworm, Bumbixmori as scientists will one day call it, is a creature of profound pickiness. It has evolved over countless generations to rely solely on the mulberry leaf. This complete dependence is the linchpin of the entire silk making process. The leaves contain specific proteins and nutrients. Yes, but also chemical attractants, olfactory cues that tell the worm, this is home, this is food. To you, it isn't science. It's just the way things are. It is an unshakable law of your universe. Caring for these trees is a year-long cycle of devotion. In the winter, you help mend the fences that keep out nibbling deer or stray goats. You gather nutrient-rich mud from the riverbank or compost from the household and work it into the soil around their roots. You inspect the bark for any signs of disease, for the tell-stale borings of insects. When spring comes, you watch the buds swell with an almost painful anticipation. The timing has to be perfect. The silkworms must hatch at the exact moment the first tender, coin-sized leaves unfurl. A mismatch of even a few days could be disastrous. Then comes the harvest, the work you are doing right now. It is not a mindless stripping of branches. You pick with discernment. The very first, most tender leaves are for the newly hatched worms. As the worms grow, you will offer them larger, more mature leaves from further down the branch. You never take too many from a single cluster, always leaving enough for the tree to continue its own life giving photosynthesis. Your movements are economical and practiced, a dance between taking and preserving. You might have heard the old masters at Sericula talk about the male and female mulberry trees. It's a piece of folk wisdom, a strange little detail that modern botanists might dismiss. They say the leaves from the female trees are broader, softer, and more nourishing for the worms. They point to the shape of the trunk, the pattern of the bark, subtle signs that you are still learning to read. While the scientific basis for this is murky at best, it speaks to the intimate relationship you have with these plants. You don't just see them as a crop, you see them as individuals, with personalities and qualities. This anthropomorphism, this attribution of human like characteristics, is a sign of ultimate respect. This deep connection also masks a complex history that even the most learned scholars of your time don't fully understand. Historians centuries from now will debate the exact lineage of your trees. They will argue over which specific species, Mora selba or another native variety, was the true progenitor of the domesticated mulberry that fuels the silk industry. They'd analyze ancient texts and pollen samples, trying to map the journey of how a wild plant was tamed, selected for its best qualities, and spread across the land. They will wonder if the trees in your grove are a pure strain or a hybrid, the result of centuries of deliberate, undocumented breeding by countless generations of people just like you. The tree you just plucked a leaf from is a living artifact, a silent witness to that long, slow history of cultivation, but its full story is a puzzle that may never be completely solved. Back at the threshold of your home, you carefully set the basket down in a cool, shaded spot. The leaves must be kept fresh. They can't be allowed to wilt. The next step isn't out in the fields, but inside, in a special room prepared with the sterile precision of a temple. You've brought the food. Now, it is time to wake the gods of this little universe. It is time to summon the eaters. You don't just walk into the silkworm room. You prepare. You wash your hands meticulously, scrubbing away the grime of the fields. You change out of your outdoor clothes into a set of clean, dedicated garments. The room itself is a sanctuary of quiet and control. The windows are covered with thick paper or cloth, blocking out harsh, direct sunlight and keeping the temperature stable. There's a gentle, earthy smell inside, a mixture of dry bamboo, old wood, and the faintest, lingering scent of last year's mulberry crop. This room is often the warmest, quietest, and cleanest place in the entire house. It must be. The tiny lives you are about to nurture are incredibly fragile. In a corner of the room, on a high shelf away from drafts and curious pests, rests a small, unassuming wooden box. Inside this box, carefully layered between sheets of soft, thick paper, is the future. You lift the lid with a reverence usually reserved for ancestral tablets. Inside, stuck to the paper, are thousands upon thousands of tiny grayish minus black dots. They are impossibly small, no bigger than a pinprick, like a sprinkling of poppy seeds. These are the silkworm eggs. Looking at them, it seems impossible that they could ever produce the shimmering, luxurious fabric that merchants travel thousands of miles to acquire. This is the very beginning of the cycle, a stage of deliberate, patient waiting. These eggs were laid last year, at the very end of the season. After they were laid, they were carefully washed, a process that is far more complex than it sounds. They would have been bathed in brine or a specific herbal solution to both sterilize them and trigger the crucial state of diapase, a kind of hibernation that ensures they don't hatch prematurely during a warm spell in autumn. Now, their long winter sleep is over, and it's your job to wake them. This isn't a matter of just waiting. It is an act of precise and gentle manipulation. You take the sheets of paper, covered in their precious cargo of eggs, and lay them out on wide, flat bamboo trays. The process of hatching or waking is all about temperature. For the past week, you and the other women in your household have been gradually warming this room. You might use a small, carefully banked charcoal brazier in the center of the floor, radiating a gentle, consistent heat. The air must be warm, but not hot. It must be humid, but not damp. You feel it on your skin. You smell it in the air. You are a human thermostat, constantly making micro-minus adjustments, adding a piece of charcoal, or sprinkling a little water on the floor to raise the humidity. The timing of this is a masterful calculation based on generations of experience. As I mentioned, you are trying to perfectly synchronize this moment, the awakening of the worms, with the availability of the first tender mulberry leaves. Hatch too early, and they will starve. Hatch too late, and the first leaves will have already become too tough for their tiny mouths. You watch the mulberry buds in the grove with the same intensity that you monitor the temperature in this room. The two are part of a single, interconnected system. One of the curious, almost ritualistic, practices associated with this stage is the use of body heat. In some households, through the final, most delicate stage of incubation, a woman might tuck the papers and eggs into the front of her robe, keeping them nestled against her skin. The belief is that the steady, gentle warmth of the human body is the perfect catalyst for hatching. It's an act of profound intimacy, treating these future worms as if they were one's own children. It might sound strange, but it highlights the deeply personal and nurturing aspect of sericula. There is no machinery here, no technology beyond your own senses and your own body. You are the incubator. As you monitor the eggs, you are participating in a process that has been refined over millennia, and yet there are still mysteries. Historians and scientists of the future will endlessly debate the specifics of these ancient techniques. They will analyze classical texts like the Nongsheng Ji Yao Fundamentals of Agriculture in Sericula to understand the ideal temperatures and timings described. They will argue whether the brine baths were merely forced sterilization or if ancient farmers had stumbled upon a sophisticated hormonal trigger without understanding the underlying biology. Was the timing determined by a simple calendar, or did they use more subtle environmental cues, like the flowering of a specific plant or the arrival of a certain migratory bird? The right way was passed down as tradition, but the scientific principles behind that tradition are a subject of ongoing scholarly investigation. The knowledge you hold is practical and proven, but the why behind it remains a kind of magic. You lean closer to one of the trays. You hold your breath, trying to see the unseeable. Days of this patient watchfulness will pass. You will tend the fire, check the leaves, and wait. Then, one morning, you will enter the room and notice a change, a subtle shift. A few of the tiny black dots will have a different quality, a faint halo. The great awakening is at hand. The rustling, chewing, ravenous heart of the silk making process is about to begin. The day it happens, the air in the silkworm room feels different. Charged with a new energy, you lean over the bamboo trays, your eyes scanning the sheets of paper. Yesterday, they were just static black specks. Today, you see movement. From the tiny eggs, creatures are emerging. They are minuscule, dark, and covered in fine hairs, looking more like a scattering of tiny, animated iron filings or a colony of ants than the plump, white worms they will become. This is why they are called ant-worms or yikan. They are barely visible, a wriggling mass of new life. Your heart quickens, but your movements must remain slow and deliberate. This is one of the most delicate moments in the entire process. These newborns are incredibly fragile. A rough touch, a sudden draft, a moment of carelessness, any of these could be fatal. You can't just scrape them off the paper. You have to coax them, to lure them onto their first meal with the utmost gentleness. You take some of the tenderest mulberry leaves you gathered, the ones you selected specifically for this day, and you chop them into impossibly fine shreds, almost to green dust. You then sprinkle this leafy confetti lightly over the hatching eggs. The worms, driven by an instinct as old as their species, will begin to stir, slowly, almost imperceptibly, crawling from their papery birthplace towards the scent and taste of their one and only food. This is the first transfer. After a while, when a good number of them have crawled onto the fresh leaf fragments, you will perform a little feat of magic. You take a single, soft feather, often a goose or chicken feather, and you use it to gently lift the leaf fragments, now teeming with ant-worms, and transfer them to their new home, a larger, flat bamboo tray called a canbo, or silkworm plate. The feather is the perfect tool, soft enough not to crush them, precise enough to pick up just the leaves. You repeat this process over and over, your movements deft and whisper minus light, until the sheets of paper are empty and the trays are dotted with new life. Once they are on the trays, your life changes. For the next month, you are no longer just a farmer or a household member. You are a full time nursemaid to thousands of demanding infants. The primary task is feeding, but you can't just dump a pile of leaves on them. The leaves must be fresh, clean, and dry. Any excess moisture can cause disease to sweep through the colony with terrifying speed. You bring in the leaves from the grove, wipe them down carefully, and then chop them to a size appropriate for the worm's current age. For these tiny ant-worms, it's a fine mince, As they grow, the pieces will get larger. The sound begins now. At first, it's imperceptible, a silence that you can almost feel. But if you hold your breath and listen with your entire being, you can just make it out a faint, continuous, rustling, crinkling sound. It is the sound of thousands of tiny mandibles slicing through tender leaf tissue. It is the sound of growth. This sound will become the backdrop to your days and nights. It will grow in volume until it is a constant, gentle shower of sound. The soundtrack of the silkworm room. A strange and fascinating bit of lore from the stage involves sound and smell. Circular manuals and folk wisdom stress the importance of quiet and cleanliness around the ant-minus worms. Loud noises, strong smells like fish or wine, and even the presence of people who are angry or upset were all thought to be harmful to the delicate worms. Pregnant women or those who had recently given birth were sometimes forbidden from entering the silkworm room for fear that some vital energy might be disturbed. While modern science would explain the need for quiet and cleanliness in terms of preventing stress and disease, these ancient beliefs framed it in a more holistic, almost spiritual way. The emotional and physical state of the caretaker was seen as directly impacting the well-minus being of the worms. You act accordingly, moving with a quiet grace, speaking in hushed tones, keeping the room free of any foreign scent. This meticulous care you're taking is the product of centuries of trial and error. But, even with all this accumulated knowledge, the exact nature of the silkworm's domestication is a topic of great debate among historians and biologists. It is clear that your Bombyx mori is a profoundly different creature from its wild ancestor. Bombyx mandarina, the wild silk moth, can fly, is adept at camouflage, and is much more resilient to environmental changes. Your domesticated silkworm, after thousands of years of selective breeding, cannot fly. Its white color makes it an easy target for predators it will never face. It has lost its instinct to do anything but eat, grow, and spin a cocoon. Scholars argue about how this transformation happened. Was it a single domestication event, or did it happen in multiple places? How long did it take to breed a worm that would produce a perfectly white, smooth, unbroken thread, rather than the rough, greenish cocoon of its wild cousin? You are living with the result of this long, mysterious process of artificial selection. The creature you are tending is, in a very real sense, a human invention. It is a biological machine, perfectly honed for one purpose, but utterly dependent on its human keepers for survival. It cannot exist in the wild. Without you, it would perish in a day. As you look at the trays of slowly wriggling black specks, you feel the immense weight of that responsibility. Their lives are, quite literally, in your hands. The days now settle into a steady, rhythmic routine, a cycle of feeding, cleaning, and watching. The silkworm room has become the center of your universe. The first thing you do when you wake is check on the worms. The last thing you do before you sleep is check on the worms. The tiny, dark ant-minus worms are growing at an astonishing rate. With each passing day, they become visibly larger, lighter in color, and more voracious. The sound is the most noticeable change. That faint, almost imaginary rustle has now grown into a distinct, audible sound. It's the sound of a gentle rain falling on dry leaves, a constant, soothing white noise that fills the room. This is the sound of thousands of silkworms eating. It is relentless. You feed them multiple times a day, spreading fresh, chopped mulberry leaves over them. They swarm the new food, their bodies piling over one another in their eagerness to eat. Within a few hours, the fresh leaves will be gone, leaving behind nothing but a network of skeletal veins. Your main job, besides providing this endless buffet, is cleaning. This is just as crucial as feeding. The worms produce a shocking amount of waste, known as frass. If this is allowed to accumulate, it creates a breeding ground for mold and disease, which can wipe out your entire crop. So a few times a day, you have to clean the trays. You can't just pick the worms up one by one, so you use a net. You lay a special mesh net over the worms and then spread the fresh mulberry leaves on top of the net. The worms, always eager for a fresh meal, will crawl up through the holes in the net to get to the new leaves. Once they have all migrated upwards, You can lift the entire net, worms and all, and set it on a clean tray. The old tray, with the leftover leaf skeletons in the frass, can then be taken out, cleaned, and prepared for the next change. It is an ingenious, labor-saving technique, honed over generations. As they grow, they will go through several distinct stages, or in stars, and the transition between them is a period of great vulnerability. This is the process of molt, or sleeping. For about a day, a worm will stop eating. It will hold its head high, become very still, and its skin will seem to shrink and grow dull. It looks for all the world like it's sick or dying. The first time you see it, your stomach clenches with anxiety, but your mother or grandmother has taught you to recognize these signs. They are not sleeping. They are preparing to shed their skin. During this time, you must be extra vigilant. You don't feed them, and you ensure the room remains as stable and undisturbed as possible. Then, the magic happens. The worm will wriggle and twist, and its old skin will split open near its head. Slowly, it will crawl out, leaving its old, shrunken pajamas behind. It emerges larger, with a fresh, pale, glistening skin, and a monstrously renewed appetite. They go through this cycle for times. With each molt, they grow exponentially. After the first molt, they are no longer fragile and minus worms. After the second and third, they are becoming the plump, white, almost translucent creatures you picture when you think of a silkworm. In the midst of this intense, focused work, there are moments of strange wonder. One of the more peculiar by-products of this whole process is the frass itself, the silkworm droppings. You don't just throw it away. Nothing is wasted. This frass is collected and dried. It's known to be incredibly rich in nitrogen and chlorophyll, making it a fantastic fertilizer for the vegetable garden. But it also has a more surprising use. It's used to make pillows. A silkworm frass pillow might sound like the last thing you'd want to rest your head on, but they were highly valued in traditional Chinese medicine. The dry, pellet-like frass has a faint, sweet, tea-like smell. The pillows are said to have a cooling effect, to be good for your eyesight, and to help calm your nerves. Whether these claims are true or not, it speaks to a philosophy of resourcefulness, where even the waste product of your primary craft has its own value and purpose. As you watch the worms grow, you are witnessing a biological miracle, but one that is still not fully understood, even by the most dedicated scholars of the future. The debate over the exact hormone and genetic triggers for molting and growth in Bombyx mori continues in scientific circles. They will map its genome and study its endocrine system, but the precise interplay of factors that allows it to convert mulberry leaves into body mass with such incredible efficiency is a marvel of biochemistry. Historians also argue about the discovery of the cleaning net. Was it a single person's brilliant idea, or did it evolve slowly? Early texts describe much more laborious cleaning methods, involving chopsticks and feathers to move worms individually. When did this leap in technology occur? It's a simple tool, a piece of mesh, but it represents a major innovation in the history of sericula, saving countless hours of labor and dramatically improving the survival rate of the worms. For you, these academic questions are irrelevant. Your knowledge is tactile. You know the exact texture of a worm about to molt. You can tell by the sound in the room if their appetite is good. You can distinguish the smell of healthy worms from the first faint, sour scent of disease. The days blur into one another, a steady rhythm of chopping leaves, spreading them, lifting nets, and cleaning trays, all set to the constant, munching, rustling soundtrack of growth. The fourth and final molt is over. The change is dramatic. The worms you are now tending to bear little resemblance to the tiny black threads that hatched a few weeks ago. They are now in their fifth and final install, a stage often called the Great Sleep or Big Silkworm phase. They are huge, by silkworm standards as thick as your little finger and nearly as long. Their bodies are a pale, creamy white, segmented and plump, with a soft, almost luminous quality to their skin. They are, in essence, eating machines that have reached their final form. and their appetite is staggering. All the eating they have done before now seems like a mere appetizer. During this final stage, which lasts about a week, a silkworm will eat more than it has in its entire life up to this point. Your days are now consumed by the harvest. You no longer need to chop the leaves. You can place whole branches, fresh from the grove, onto the trays. The sound in the room has reached its crescendo. It's no longer a gentle rain. It's a downpour, a constant, loud, crispy, crackling roar as tens of thousands of powerful mandibles tear through leaf after leaf. It's a sound that fills the house, a constant reminder of the intense, biological process happening in that one room. You are running an on-stop mulberry leaf shuttle service. The baskets are heavier. The trips to the grove are more frequent. The trees that looked so lush and fun a month ago are beginning to look a little sparse. You are strategically stripping them, moving from one tree to the next to give the others time to recover. The work is physically demanding, but there's a sense of thrilling anticipation in the air. This is the final push. All the careful nurturing, the sleepless nights, the constant cleaning, it's all about to pay off. During this phase, you have to be more careful than ever about space. The worms have grown so much that their trays are becoming crowded. Overcrowding can lead to stress, disease, and lower quality cocoons. So you have to continually expand their living quarters, bringing in more and more of the large, flat bamboo trays, spreading the colony out to give each worm enough room to eat. Eventually, to spin, the silkworm room, once spacious, is now filled to capacity with stacks of these trays, creating a sort of silkworm metropolis with a population in the tens of thousands, all of them eating. It's during this phase of intense feeding that one of the more unusual culinary footnotes of the silk industry sometimes appears. While the goal is the cocoon, the worm itself has, at various times and in various regions, been a source of food, especially in areas where protein was scarce. The plump, nutrient-rich silkworm pupae after the silk has been reeled from the cocoon were often fried or roasted as a delicacy. Some historical accounts even mention eating the lard, in starworms themselves, before they spin. To you, it might seem unthinkable to eat one of the creatures you so carefully nurture, but it's a stark reminder that in a world without supermarkets in abundance, every resource was evaluated for its potential. The silkworm was primarily a fiber producer, but it was also, secondarily, a tiny, edible livestock. This final, gluttonous stage is a biological necessity. The worm is not eating for its own survival anymore. It is stockpiling all the protein and energy it will need for its next great act, the spinning of the croton and its transformation into a moth. It is converting mulberry leaves into liquid silk. Inside its body, 2 large glands are swelling, filling with a viscous fluid called fibroin, which is the protein that will form the main filament of silk. Another pair of glands produces S-arygin, a gummy substance that will bind the filament together. The worm's entire body is becoming a factory, preparing for its final, magnificent burst of production. The precise nutritional science behind this is something that scholars will puzzle over for centuries. They will debate how the specific amino acid profile of mulberry leaves is so perfectly suited for conversion into silk protein. The efficiency is extraordinary, a level of biochemical engineering that humans would struggle to replicate. Historians, meanwhile, will argue about the scale of ancient circular, reading texts that describe households raising hundreds of thousands of worms. They'll try to calculate the sheer logistics of it. How many mulberry trees would be needed? How many people would it take to harvest that many leaves every day? The numbers become staggering, suggesting that successful sericulate wasn't just a cottage industry, but a massive agricultural undertaking, requiring immense planning and labor. The roar in your silkworm room is a small scale echo of that massive, empire-wide effort. Then, after about a week of this frenzied, non-stop feasting, a change occurs. You walk into the room one morning and the roar is diminished. A hush has begun to fall. You look at the trays. A few of the worms have stopped eating. They are ignoring the fresh leaves you've just laid down. This is the sign. The great feast is ending. The time for spinning is near. The roar of chewing subsides, replaced by a new kind of sound, a restless rustling. The feast is over. A wave of change is sweeping through the silkworm population. You watch them closely, your eyes trained to spot the subtle signals you've been taught to recognize since you were a child. This is the moment of diagnosis, where you identify which worms are ready for the next, and perhaps most magical, stage of their lives. A worm that is ready to spin undergoes a visible transformation. Its body, once a creamy, opaque white, starts to become translucent, particularly around its head and neck. It looks as if it's been carved from a piece of pale, milky jade. If you were to hold it up to the light, which you do, very gently, you could almost see the reservoirs of liquid silk shimmering within. Its body also seems to shrink slightly, becoming you turn more compact as it purges the last of its waste. It is preparing its body, making it a lean, efficient spinning machine. The most obvious sign, however, is its behavior. It stops eating entirely. A perfectly fresh, tender mulberry leaf, which just yesterday would have been devoured in minutes, now holds no interest. Instead, the worm becomes agitated. It lifts its head, waving it back and forth, as if scanning the horizon for something. It begins to crawl, not towards food, but towards the edges of the tray. It's searching. It's looking for a place to build its house. It needs a corner, an angle, a structure to which it can anchor its first precious filaments of silk. If left on the flat tray, it would wander aimlessly, wasting its precious silk, or spin a flat, useless mat. You must provide it with a suitable building site. You begin the delicate process of picking the right. You scan the trays. You're experienced at quickly identifying the translucent, wandering worms. One by one, you gently pick them up. They feel different now, firmer, more muscular. You place them into a separate, clean basket, ready for relocation. It's a slow, methodical process. Over the next few days, more and more worms will ripen, and you will continue this harvest, separating the spinners from the eaters until all the trays are clear. This moment of ripeness has a curious, if slightly gruesome, little quirk associated with it. For a brief period, before modern refrigeration, the ripe silkworms that were not needed for spinning, or were perhaps of a lower quality, were used for another purpose: fish bait. Their constant, wriggling motion and tough skin made them an excellent and highly prized bait for catching freshwater fish. It's another small example of the pragmatic, no minus waste philosophy that governed rural life. While 99% of these worms are destined for a far more glamorous future, it's a reminder that they were still a part of a practical, agricultural ecosystem. This ability to recognize the exact moment of ripeness is crucial. Move them too early, and they will not have stored enough protein to spin a strong, complete cocoon. Move them too late, and they may have already started spewing silk onto the tray, tangling with their neighbors and creating a messy, unusable floss. Your judgment, based on sight and touch, is the only tool you have, and it's a judgment that has been passed down through generations. But even so, there's an element of it that remains mysterious to outsiders. Future historians will pore over ancient circular manuals, which often use beautifully poetic, but frustratingly vague language to describe this stage. They might say the worm becomes like melting snow or has the luster of pearl. Scholars will debate the exact meaning of these phrases. Are they describing a specific level of translucent, a measurable change in the worm's skin tension? They'll try to cross-reference these artistic descriptions with modern entomology, acknowledge, to pinpoint the exact physiological changes the ancient writers were observing. The challenge is translating this intuitive, sensory knowledge that you possess into the objective, scientific language of a later era. The knowledge in your fingertips is something that a book can describe, but never truly capture. You have a basket full of restless, translucent worms now. They are ready. They are full of liquid gold. The simple bamboo trays that have been their home and their restaurant are no longer sufficient. They need a different kind of architecture now, a place with nooks and crannies, a 3-dimensional space where they can perform their solitary, miraculous act of creation. The sun is low in the sky, and there is one more major task to complete before nightfall. It's time to move them into their golden palaces. With your basket of ripe silkworms, you move to the final piece of architecture in the silkworm room, the cocooning frame, or the sea. This isn't a flat tray. It's a 3-dimensional structure designed specifically for this moment. It can take many forms. Sometimes it's a large, flat board with hundreds of individual straw-lined compartments, like a miniature honeycomb. More often, it's a specially designed bundle of straw or twigs, often called a mountain of straw, bound together to create a labyrinth of inviting nooks and crannies. You take the restless worms from your basket, one by one, and place them onto the sea. As soon as a worm finds a suitable spot, a tight corner, a junction of two straws tucks it immediately gets to work. Its behavior changes from agitated wandering to focused construction. First, it casts out a series of thin, irregular threads, creating a loose, fuzzy net around itself. This is the scaffolding, the sling that will hold the main cocoon in place. This outer layer is called fuzz, or blaze. It's rough and less valuable than the main cocoon, but it's a critical first step. Once this outer harness is secure, the real work begins. The worm starts to move its head in a steady, rhythmic, figure-8 pattern. From its spinneret, a small opening just below its mouth, a single, continuous thread of liquid silk emerges. This isn't actually one thread, but two. The two fibroin filaments emerge from their separate glands and are fused together by the sticky esoteric in gum, just as they exit the spinneret. As this double minus filament hits the air, it solidifies. The worm meticulously rotates its entire body, laying down layer after layer of this single, unbroken thread, wrapping itself in a silken tomb that is also its cradle. You step back and watch. The room is quiet now, save for the faint, dry rustle of worms positioning themselves in the straw. It's a slow, mesmerizing process. Over the next 2-3 days, the worms will be completely consumed by this task. They do not stop. They do not eat or drink. They pour all the energy they stored during their final feast into this one act of creation. Slowly, the fuzzy outlines of the first slings give way to more solid, opaque, oval shapes. The worm gradually disappears from view, sealing itself inside its own creation. The CU begins to look like it's been decorated with hundreds of puffy, white or pale-yellow jewels. It's a moment of quieter. You are witnessing one of nature's most extraordinary feats of engineering. The cocoon is a marvel of design. It's light, yet incredibly strong. The layers of silk create a thermo-regulated environment, protecting the pupa inside from temperature fluctuations. It's breathable, allowing for oxygen exchange, but also water-resistant, protecting it from the rain it would face in the wild. In the midst of this architectural wonder, a strange little belief sometimes surfaces among the older, more superstitious keepers. They might say that a CU that fills up quickly and evenly with perfectly formed cocoons is a sign of good fortune for the family in the coming year. A messy CU, with many worms spinning together or creating flat, now-formed cocoons, is a bad omen. This links the quality of the silk harvest not just to economic success, but to the family's cosmic luck. It's a way of reading the future in the patterns of the present, adding a layer of divination to the practical task at hand. The structure of the cocoon has fascinated and baffled observers for millennia. The fact that it is spun from a single, continuous thread is the secret to its value. If the worm were to chew its way out after its transformation, it would break that thread into thousands of short, unusable pieces. The length of this single filament is astonishing. It can be anywhere from 600 to 900 meters long, or even longer. That's nearly a kilometer of silk, all perfectly coiled by a single, tiny creature to form a shelter the size of your thumb. Historians and material scientists will, of course, study this for centuries. They'll debate the precise mechanics of the spinning process. How does the worm control the thickness and tension of the thread? How does it manage to layer it so perfectly as to create a uniform, strong structure without ever seeing what it's doing. They will use electron microscopes to analyze the crystalline structure of the fibrin and the adhesive properties of the S-arachion. They will argue about the evolution of this behavior, what environmental pressures led Bombyx ancestors to develop such an elaborate and energetically expensive form of self-preservation. The cocoon you are looking at is a perfect biological artifact, and the complete blueprint for its construction is a code that science will spend centuries trying to crack. For now, you just watch as the last of the worms disappear behind their silken walls. The sea is full. A quiet stillness descends upon the room. The frantic period of growth and activity is over. Now begins a period of waiting. Inside each of those perfect oval shells, a profound transformation is taking place. The worm is dissolving, reforming, preparing to become a moth. But for the vast majority of them, that journey will never be completed. A difficult, but necessary, choice lies ahead. About a week passes in relative quiet. The silkworm room is still. The only task is to wait. You are waiting for the creature inside the cocoon, the pupa, to harden. If you were to harvest the cocoons too early, the pupa would be soft and fragile, and the process of handling them could damage the cocoon or stain the silk. After about 8 to 10 days, the time is right. The transformation inside is well underway, and the pupa is firm. It's time to harvest the silken treasures. You and the other women of the household begin the careful work of plucking the cocoons from the sea. You handle them gently, twisting them slightly to break the fine flossy threads that anchor them to the straw. You collect them in wide, shallow baskets. As you work, you are also sorting. This is the first critical stage of quality control. Your fingers and eyes are your instruments. You are looking for the select cocoons. These are the ones that are a uniform color, usually a pure, bright white, though some breeds produce lovely pale yellow or greenish cocoons. They should be firm to the touch, with a pleasing heft. They should be a perfect oval shape, not too pointed, not too round. These are the grade A cocoons, the ones that will produce the longest, strongest, most lustrous thread. You set these prize cocoons aside in their own special basket. Then you have the others. There are the doubles, or pupae. These are large, irregular cocoons where two worms, perhaps getting a little too friendly, decided to spin their homes together. They are lumpy and thick, and because two threads are intertwined, they cannot be unreeled into a single, fine filament. They aren't useless, though they will be used to produce a coarser, textured type of silk known as shantan. There are also cocoons that are smaller, or had a weak, thin shell, or are stained. These are also sorted into separate piles. They will be processed differently, perhaps used for producing silk wadding for quilts or jackets, or spun into shorter, less luxurious yarns. Every cocoon has a purpose, but only the best are destined for the loom. Once the sorting is complete, you face the most crucial and, from a certain perspective, the most brutal part of the entire process. The pupa inside the cocoon must be killed before it completes its transformation into a moth. If the moth were allowed to emerge, it would secrete an enzyme to soften one end of the cocoon and then chew its way out, breaking that single, precious, kilometer-long thread into a million useless pieces. The entire point of the last month of tireless work would be ruined. To preserve the integrity of the thread, the moth's life must be sacrificed. This is the stifling or baking of the cocoon. The most common method is heat. You will carefully lay the sorted cocoons out on wide trays and place them under the hot sun for a day or two. The intense heat penetrates the cocoon and kills the pupa inside without damaging the silk. On cloudy days, or for larger operations, the cocoons might be baked in a specially designed, gently heated oven, or steamed over hot wood. The goal is to kill the pupa quickly and cleanly. It's a star, pragmatic reality that underpins the entire industry. Duty requires sacrifice. However, a small number of the very best cocoons are spared this fate. You select a handful of the most perfect specimens from your grade A basket. These will be allowed to mature. They are the future of your silkworm stock. They are your breeding pairs, chosen for their superior qualities. ensuring that next year's generation will be just as strong and productive. These chosen few are set aside in a separate, quiet place to complete their life cycle. This act of selection and sacrifice leads to a curious and slightly macabre bit of historical trivia. The dried pupae inside the baked cocoons were not always thrown away. As mentioned before, they were a valuable source of protein. After the silk was reeled off, the cooked pupae would often be collected, salted, and fried or roasted. They were a common snack in silk miners producing regions, providing a nutritional boost to the farmers. It's a perfect example of the circular waste minus not economy of the past. The waste product of the luxury goods industry became a humble, practical source of food. The morality and methodology of this stifling process is something that later generations, far removed from the practicalities of your life, will debate. Animal rights activists will question the ethics of sacrificing millions of living creatures for a luxury fabric. Historians, on the other hand, will focus on the technological aspects. They will argue about which method sun miners drying, baking, or steaming was most efficient and widespread. They will analyze how the development of better stifling techniques improved the quality and quantity of silk production. They will debate whether the ancient Chinese understood the life cycle in a scientific sense, or if their methods were simply the result of trial and error if we let them hatch. The thread is ruined if we heat them. It is not. The rationale behind your actions is simple pragmatism, but for future scholars, it's a complex intersection of technology, biology, and ethics. For now, you don't dwell on these larger questions. The baskets are full of sorted, baked cocoons. They are dry and light, and they make a soft, rattling sound when you shake them, like tiny maracas. The life within has been stilled. The precious thread is now preserved, locked inside, waiting to be released. The next stage of the journey will take you from the quiet of the silkworm room to the heat and steam of the reeling basin. The scent in the air changes. You move from the dry, earthy smell of the silkworm room to a new environment, one filled with the humidity of steam and the warmth of a fire. This next stage takes place around a small stove or hearth, upon which sits a basin of water. This is the heart of the reeling process. The cocoons you so carefully harvested and baked are now ready to give up their treasure, but the secret is locked away by a stubborn, invisible glue. Your task is to unlock it. The thread of the cocoon, as you know, is made of two fibrin filaments held together by a gummy protein called S-arakin. This S-arakin is what makes the cocoon hard and resilient. It's also what makes it impossible to unravel when dry. To release the thread, you must soften this S-arakin, and the key to that is hot water. You fill the shallow basin with clean water and heat it over the charcoal stove. The temperature has to be just right, not boiling, which could damage the delicate silk filament and make it brittle, but hot enough to dissolve the S-arakin. You learn to judge the temperature not with a thermometer, but with your hands and eyes. You watch the way the steam rises from the surface. You test it with a quick, practiced dip of your fingers. It should be hot, but not scalding. Once the water is at the perfect temperature, you drop a handful of the baked cocoons into the basin. They bob on the surface for a moment before becoming saturated and sinking slightly. You let them soak for a few minutes, the hot water working its magic, permeating the dense layers of silk and softening the gummy S-arakin. Then comes the part that requires a delicate, almost magical touch, finding the end of the thread. You can't just reach and ungrab a thread. It's too fine, too elusive. Instead, you use a special tool. It might be a small whisk made of fine twigs or a coarse brush made of rice straw. You gently stir the cocoons bobbing in the hot water. The bristles of the brush catch on the loose outer frost at first. Rough layer the worm spun. As you lift the brush, you pull up a tangle of these coarse fibers from several cocoons at once. You pull this fuzzy tangle away, and this is where the real skill comes in. With your other hand, you deftly work through this floss, your fingers searching for the single, true, continuous filament from each cocoon. The floss is discarded, and what's left, held between your fingers, are several impossibly fine, nearly invisible threads, the beginnings of the main filament from each of the cocoons you're working. This moment of finding the true end is called zushu. It's a moment of discovery, of finding order in the chaos. This process gives rise to a rather charming piece of linguistic trivia. The Chinese character shu, which depicts silk threads being sorted, has come to mean the beginning, the clue, or the thread of an idea. So, when someone in the future says they are finding the thread of an argument, or looking for a clue to a mystery, their words carry a faint, ghostly echo of this very moment of you, leaning over a steaming basin, using your fingertips to find the single, true beginning of a silk filament. Once you have found the ends of several cocoons anywhere from 4 to 8, depending on the desired thickness of the final thread, the next stage of reeling can begin. But this initial discovery is everything. It is a testament to the sensitivity of the human hand. No machine, for centuries, could replicate the gentle, discerning touch required to brush the bobbing cocoons and isolate those perfect single threads from the messy outer floss. The methods for this stage, while seemingly simple, are a subject of much scholarly discussion. Historians and archaeologists who study ancient silk production often debate the specifics of the tools and temperatures used. Some ancient texts are very precise about the ideal water temperature, while others are more vague. They analyze residue on ancient pottery basins to understand what kind of water was used. Was it pure? Or were certain minerals or even plant-based additives used to help dissolve the acericin more effectively? Some theories suggest that specific types of wood were preferred for the stirring whisks, believing their texture was superior for catching the floss without snagging the main filament. This low-tech part of the process is actually a highly refined system, and the precise details of its optimization are still a matter of academic inquiry. You have the ends now, a small cluster of them, maybe 6 in total, pinched between your wet fingers. They are so fine they are almost invisible, yet together they possess a surprising strength. The cocoons float patiently in the warm water, waiting. The fire under the basin glows steadily. The room is humid and warm. You are poised at the precipice of creation, holding the very beginning of a thread that could stretch for miles. The stage is set for the steady, rhythmic magic of unreeling the silk. Holding the cluster of near-invisible filaments between your fingers, you move to the reeling machine. Don't picture a massive, industrial apparatus. The device before you is an elegant, human-powered construction of wood and bamboo. It consists of a large, slowly rotating wheel or reel, often hexagonal or octagonal, connected by a simple doctor belt or gears to a handle that you or an assistant will turn. Your job is to guide the thread from the basin onto that spinning reel. You pass the filaments you've gathered through a tiny guide ring, usually made of polished porcelain or jade, positioned directly above the basin. This tiny ring is crucial. It wipes off excess water and acericin, and it helps to press the individual filaments together, fusing them into a single, uniform thread. The sticky, semi-dissolved acericin that still clings to the threads now acts as its own adhesive, binding them together as they cool and dry in the air. With the thread through the guide ring, you attach it to the large reel. Then, the rhythm begins. Someone starts to turn the handle. The reel begins to rotate with a steady, unhurried pace. Your hand, positioned between the basin and the guide ring, becomes the master controller of the thread. You must maintain a constant, even tension. If you pull too hard, the delicate filament will snap. If you let it go slack, the thread will be uneven and lumpy. Your fingers feel the pulse of the thread, making minute adjustments. A constant, sensitive feedback loop between you and the machine. As the reel turns, it pulls the silk from the cocoons floating in the basin. You watch them dance and bob, spinning in the water as their single, continuous thread and winds. It's a mesmerizing sight, but it's not a passive one. Your full attention is required. A cocoon's thread is not uniform. It's thinner at the beginning and end, and thickest in the middle. To create a final thread of even thickness, you must constantly add in new filaments. When one of the cocoons in the basin runs out of thread and it's thin, tapering a layer is all that's left. You must, with your free hand, Quickly find the end of a new cocoon you've had soaking, and deftly twist its filament into the group being real. This has to be done on the fly, without stopping the machine. Your hands move with a practiced, seamless grace, one guiding the thread, the other feeding in new ones, ensuring the final strand remains a consistent size. This skill of adding new cocoons is the true art of the reeler. An expert can do it so smoothly that it's impossible to see the join in the final thread. This is why a skein of reeled silk is so much stronger and more uniform than spun silk, which is made from short, broken fibers. This is the secret to its unparalleled quality. In the midst of this focus, repetitive work, a little minus known problem can arise: static electricity. As the silk thread runs through the guide onto the dry, wet and reel, the friction can generate a surprising amount of static, especially in dry weather. This can cause the fine filaments to repel each other, making them difficult to handle and resulting in a fuzzy, messy thread. Ancient reelers developed simple but clever solutions for this. They would keep the air in the room humid, often by having bowls of water nearby. Sometimes the reeling machine itself would have parts that were kept deliberately down. It's a small detail, a practical solution to a physics problem that they wouldn't have understood in scientific terms, but they knew how to solve it through observation and experience. The thread building up on your reel is called raw silk, or shangxi. It is beautiful, with a soft luster, but it's still stiff and slightly rough to the touch because of the residual aceric. The transformation into the soft, shimmering silk everyone imagines will come later. For now, the goal is to produce a perfect, unbroken skein of this raw silk. The very existence of this complex reeling machine prompts a fascinating debate among historians of technology. While simple spindles for spinning wool or hemp have existed since prehistory, this device is far more sophisticated. It requires precisely fitted gears or doctor mechanisms, a large, balanced reel, and specialized components like the porcelain guide minus ring. When was this machine invented? Archaeological evidence is scarce. As wood and bamboo decay, scholars have to rely on descriptions in ancient texts and depictions in art. They argue whether the machine was a single, revolutionary invention or the product of slow, incremental improvements over centuries. Did a foot minus pedal minus powered version, which would have freed up both of the reeler's hands, develop at the same time in different regions? Or did the innovation spread from a single source? The machine before you is the elegant result of this long, often undocumented history of innovation. You keep working, your body locked in the rhythm of the reel. You feed, you guide, you watch. The cocoons spin, shrink, and are replaced. The thread flows in a continuous, shimmering line from the water to the wheel. Slowly, steadily, a thick, pale band of raw silk builds up on the reel, a testament to your skill and patience. The reel slows to a stop. Before you is the fruit of your labor, a magnificent, thick band of raw silk, glistening with a pale, buttery sheen. The color isn't a pure white, but a creamy yellow or off minus white, the natural color of the aceric in gum that still coats and binds the filaments. The reeling is done, but the thread is not yet ready. It's currently in a large, continuous loop on the reel, and you need to get it off in a way that is manageable and won't turn into a catastrophic tangle. This is the process of forming the skein, or ray minus reeling. With great care, you gently slide the entire mass of silk off the octagonal reel. You now have a giant, beautiful loop of raw silk. If you were to just dump this in a basket, you would spend the next year trying to untangle it. So you must secure it. You take shorter lengths of waste silk or cotton thread and tie the loop in several places. This keeps the threads parallel and organized, preventing them from tangling. Then, you perform a motion that is both simple and deeply satisfying. You take the large loop and twist it. You twist and twist until it coils back on itself, forming a thick, self-contained bundle of silk. This twisted bundle is called a hank or a skein, or in Chinese, a jiao. This is the standard, saleable unit of raw silk. It's a compact, stable form that can be easily stored, transported, and sold. When you see ancient paintings of the Silk Road, with camels laden with goods, This is what the silk would have looked like, not bolts of fabric, but dense, valuable hanks of raw silk thread, ready for the dye pots and looms of distant lands. You handle the finished skeins with a sense of pride and accomplishment. Each one represents thousands of cocoons, countless hours of feeding worms, and the intense, focused skill of the reeling process. You weigh them on a simple balance scale. The weight of the silk your household produces is a direct measure of your success for the year. This weight translates into income, into the ability to buy salt, tools, or perhaps save for a daughter's dowry. These skeins are not just thread, they are concentrated value. A fascinating, and often overlooked, aspect of this stage is the role of the aceric in itself. While it's seen as an impurity that will eventually be washed away, it's incredibly useful at this stage. This gummy coating, which makes up about 20–30% of the raw silk's weight, acts as a protective layer. It makes the thread stronger, more resilient, and less likely to snag or fray during the rough and minor stumble processes of transport and trade. It's like a natural starch that keeps everything in order. The weavers and dyers who buy your silk will be the ones to remove it. But for you, the producer, it's a vital part of delivering a high quality, stable product. The removal of this gum is what will eventually create the dramatic difference between raw, silk and finished silk. The very form of the skein, this twisted hank, is a testament to ancient ingenuity, but its standardization is a topic of ongoing historical debate. As the silk trade grew from a local affair to a massive empire spanning industry, there must have been some level of standardization. Merchants needed to know what they were buying. Did governments or guilds impose regulations on the weight and quality of a standard skein? Historians search for evidence of this in ancient economic records and legal documents. They argue about how these standards were enforced. Were there official inspectors? What were the penalties for selling underweight or pure quality silk? The skein you hold in your hand is likely made to a customary, local standard, a good weight that everyone in your village understands. But how that standard connected to the larger commercial world is a complex puzzle that economic historians are still trying to piece together. You stack the finished skeins in a dry, safe place, away from moisture and pests. Looking at the pile, you can see the culmination of a whole season's work, from a box of tiny, pinprick-sized eggs to this lustrous heap of raw potential. But the journey of this thread is far from over. It is still stiff, still its natural, creamy color, before it can become the vibrant, flowing fabric of a scholar's robe or an empress's gown. It must be purified, it must be washed, cleansed, and reborn. The next step will be to strip away its protective gummy shell and reveal the true, brilliant soul of the silk that lies beneath. The next phase of the journey requires a different kind of alchemy. You've transformed leaves into worms and worms into thread. Now, you must transform that stiff, raw silk into the soft, luxurious material renowned across the world. This is the process of degumming, or what artisans call refining or scouring the silk. Your goal is to wash away the aceric in that protective, glue-like protein to reveal the pure fibro and filaments underneath. You twist one of the hanks of raw silk back into its large loop and place it in a vat of warm, soapy water. But this isn't just any soap. For centuries, the best soap for this purpose was a simple, natural, and highly effective alkali solution made from plant ash. You might use the ash from burned rice stalks, bean pods, or specific types of wood. This ash is rich in potassium carbonate and other natural salts that, when mixed with water, create a gentle, effective detergent. You let the skeins soak in this warm, slightly slick feeling solution, agitating them gently from time to time. Slowly, the aceric begins to dissolve and wash away. The water in the vat turns cloudy and yellowish brown. As the gum dissolves, the silk undergoes a magical transformation. It loses a significant amount of weight, up to 30%, as the heavy aceric is removed. What's left is lighter, softer, and dramatically more lustrous. The individual filaments, no longer glued together, can now move freely, giving the thread its characteristic suppleness and drape. The color also changes, lightening to a brilliant, almost snow-like white. You are, in essence, polishing the thread at a microscopic level, revealing the smooth, triangular, prism-like structure of the fibro and filaments that will catch and reflect light so beautifully. After the alkali bath, the skeins must be rinsed thoroughly in clean water, perhaps in a running stream, to remove any last traces of the ash and the dissolved gum. You then gently squeeze out the excess water and hang the great, dripping loops of purified silk to dry in a shady, breezy spot. Direct sunlight is avoided, as it can yellow and weaken the delicate fibers. As it dries, you will see the final result, a skein of what is now called cooked silk, or SHOSI. It is impossibly soft to the touch, with a deep, radiant luster. This is the silk of legend. This process, while effective, had its own interesting quirks. One of the more peculiar historical side notes is the use of another natural substance for degumming pig's bile. While plant ash was common, some historical texts on textile production mention using bile from the gallbladders of pigs, mixed with water, as a powerful degumming agent. The enzymes in the bile were apparently very effective at breaking down the acerican protein. It's a slightly less romantic image than a bath of pure spring water and dash, but it speaks to the resourcefulness of ancient artisans, who were masters of organic chemistry without ever knowing the names of the molecules they were manipulating. The perfection of this degumming process was a major technological achievement, but its origins are, like so many steps in this story, a matter of some debate among scholars. When did our ancestors figure out that an alkaline solution was the key? Did they first notice that washing silk in the water of certain streams that happened to be naturally alkaline produced a better result? Or was it a more deliberate process of experimentation with different substances? Historians of science study ancient chemical recipes and workshop remains, trying to trace the evolution of this technique. They argue about the sophistication of the process. Did ancient artisans understand the concept of a pH scale, even in a rudimentary way? Or was it all based on past minus down wisdom? Use the ash from this plant, soak it for this long, at a temperature that feels this warm. The line between folk knowledge and early science is incredibly blurry here. You hold the finished skein of cooked silk. It feels weightless, ethereal. It shimmers in the soft light. This pure white thread is now blank canvas. It is beautiful on its own, a symbol of purity and elegance. But its potential for even greater beauty is about to be unlocked. This pristine, absorbent, and brilliant white thread is now perfectly prepared to receive color. The journey now moves from the world of biology and mechanics to the world of art and chemistry. It's time to visit the dye vats and give this silk a vibrant new soul. You take the skeins of brilliant, degummed white silk and carry them to another part of the workshop, one where the air is thick with a different set of smells, earthy, pungent, sometimes sweet, sometimes acrid. This is the domain of the dye. Here, you see large ceramic vats, some simmering gently over low fires, others sitting cold, filled with liquids of various hues. This is where the blank canvas of your silk will be painted with the colors of the natural world. The art of dyeing is as ancient and secret as circulate itself. Every color comes from a plant, an insect, or a mineral. To get a vibrant, lasting color, you can't just dip the silk in berry juice. It requires a deep understanding of chemistry, of modern tests, and of complex, multi-step processes. Let's say you want to dye the silk a brilliant, sunny yellow, a color favored for the robes of scholars and high officials. You would start with the seed pods of the gardenia flower. You crush the dried pods and steep them in hot water, creating a beautiful, golden yellow liquid. But before you can put your precious silk in there, you must prepare it with a mordant. A mordant is a substance that helps the dye molecule bind chemically to the fiber. Without it, the color would just wash out. A common mordant is alum, a mineral salt that you would dissolve in water. You first soak the silk skein in the alum solution. Then you transfer it to the warm gardenia bath. The alum acts as a bridge, grabbing onto the silk fiber with one hand and the dye molecule with the other, locking the color in permanently. What if you wanted a rich, royal red. The source for that is often the root of the madrepare. The roots are dried and ground into a powder, then carefully heated in water to extract the crimson dye. The process can be incredibly complex, involving multiple baths and different mordant tests to achieve different shades, from a soft pink to a deep blood red, and for the most prized color of all, a deep, luxurious blue, you would turn to the indigo plant. The process for creating an indigo dye that is true alchemy and one of the most complex in the ancient world. It doesn't involve heat. The leaves are composted and fermented in an alkaline solution, often using more of that useful plant ash and sometimes stale urine, which is rich in ammonia. This creates a greenish-yellow liquid. You dip the silk into this, seemingly a blue vat. When you pull it out, it's a pale, sickly yellow-green. But then, as it hits the oxygen in the air, the magic happens. Before your very eyes, the color transforms, shifting from green to a deep, profound blue. It is one of the most dramatic and inspiring processes in all of dyeing. One of the more peculiar and high-status dyes in the ancient world came not from a plant, but from an insect. To get a specific, brilliant crimson or scarlet color, dyers would sometimes use crushed scale insects, like Chiamis or Cochinol, though the latter was a New World discovery. The process involved collecting thousands of these tiny insects from host plants, drying them, and crushing them into a powder. The resulting dye was incredibly potent and expensive, reserved for the highest echelons of society. The idea that a beautiful red robe might owe its color to a vat of crushed bugs is a strange thought, but it highlights the incredible ingenuity and resourcefulness of ancient dyers. You, as the dyer, are a master of these secret recipes. You know how to modify the colors, creating a whole palette from just a few base ingredients. By adding a bit of iron, perhaps from rusty nails steeped in vinegar, to a yellow dye bath, you can sadden the color, turning it into a muted olive green or a somber gray. By first dyeing a skein yellow and then dipping it into the indigo vat, you can create a vibrant, living green. The exact recipes and techniques for these dyes were closely guarded secrets, passed down from master to apprentice, and they are a source of endless fascination and debate for modern historians and chemical archaeologists. They try to replicate these ancient processes to understand them better. They analyze microscopic dye particles on ancient textile fragments to identify the exact plant or mineral source. They argue about the purple of the Forbidden City. Valterian purple, from sea snails, was famous in the West. The specific formulas for certain imperial purples in China were exceptionally rare and complex, sometimes involving a painstaking combination of madder, red and indigo blue. The precise formula for a specific shade of emperor yellow or palace red is a piece of lost knowledge that science is still trying to rediscover. You pull a skein of silk from the indigo vat. It drips a deep blue onto the stone floor. You hang it up, and the color sets as it dries. You look around at the loops of silk hanging everywhere, a rainbow of brilliant color, sunny yellows, deep reds, sky blues, and rich greens. The thread is now beautiful, vibrant, and alive with color. It has completed its journey through the world of liquids and dyes. Now, it is ready for the final stage of its creation. It is ready for the solid, rhythmic, and intricate world of loom. The dyed and dried skeins of silk are now ready for the loom. But you can't just take a hank of silk and start weaving. The final, and perhaps most mentally taxing, preparation now begins warping the loom. This is the process of setting up the longitudinal threads, the woof, which form the backbone of the fabric. It is a task that requires immense patience, precision, and a good head for mathematics. First, you must transfer the silk from the skeins onto bobbins or spools. You place a skein on a spinning holder called a swift, find the end of the thread, and wind it onto a small bamboo bobbin using a spinning wheel. You do this over and over, transforming the large, coiled hanks into dozens, or even hundreds, of small, manageable spools of thread. The room fills with the soft whirring of the wheel. Now, for the loom itself, picture a large, complex wooden frame. At the back is the warp beam, a large roller onto which all the warp threads will be wound. At the front is the cloth beam, where the finished fabric will be collected. In between is a dizzying array of components headless, harnesses, and a reed. Your job is to thread hundreds, sometimes thousands, of individual silk threads from the bobbins through all these components in the correct order. You use a warping board or frame. This is a large wooden rack with pegs sticking out of it. You take the threads from your spools and walk back and forth along the board, wrapping the threads around the pegs to measure out the exact length and number of warp threads you need for your piece of cloth. This process groups the threads and keeps them in order. Once you have your massive bundle of warp threads, the true test of patience begins. You must thread each one, individually, through its own heddle. A heddle is a thin cord or wire with a tiny I- hole in the middle. These headless are held in frames called harnesses. By lifting a harness, you lift all the threads that pass through its headless. This is what creates the shed, the opening through which the weft thread will pass. For a simple plain weave, you only need 2 harnesses. But for more complex patterns, you might need 4, 8, or even more. After passing through the heddle, each thread must then pass through a gap in the reed. The reed is a comb-swag device that keeps the threads evenly spaced and is used to beat the weft thread into place. So, for every single thread in your warp, you must pass it through a heddle eye, then pass it through a reed gap. Imagine doing this for 2 zero threads. It is a painstaking, I-training, mind-numbing process. A single mistake, 1 crossed thread, 1 missed heddle can disrupt the entire pattern and may not be discovered until you've already started weaving. This meticulous, almost meditative, preparation phase gives rise to a quirky little bit of weaver's lore. It was often considered bad luck to be interrupted while dressing the loom. A sudden noise, a distracting question, these could cause the weaver to lose their count or thread a heddle. As a result, weavers often sought complete silence and solitude during this process. Some even developed elaborate systems of not-so-colored threads to mark their progress, a kind of personal, temporary code to help them keep their place if they were forced to stop. The complexity of the ancient Chinese loom, particularly the draw loom used for complex patterns, is a marvel of engineering that still fascinates historians of technology. While simple looms are found in many cultures, the Chinese developed incredibly sophisticated machines capable of weaving complex brocades and damask. The debate among scholars often revolves around the evolution of the heddle. When did weavers move from simply picking up threads with their fingers or stick to this system of harnesses that could lift hundreds of threads at once in a pre-programmed pattern? The invention of the multi-harness loom was a technological revolution on par with the printing press, allowing for the mass production of complex patterns that were previously impossible. They argue about the origins of the draw loom, a massive machine that required to operate as 1 weaver and 1 draw-boy, who sat atop the loom lifting patterns of threads. The precise timeline for these innovations is still being pieced together from artistic depictions and rare archaeological finds. You finish threading the last warp thread. You tie them all securely to the front cloth beam. You wind the entire length of the warp onto the back beam, adjusting the tension until it is perfectly taut and even. The loom is finally dressed. It stands before you, a silent harp with 1,000 silk strings. Each thread is in its place, a line of pure color waiting to be interlaced with another. The mathematical, preparatory phase is over. The rhythmic, creative phase is about to begin. You can finally sit down on the weaver's bench, the potential for a beautiful cloth stretching out before you. You finally sit at the weaver's bench. The whole preparatory work is done. The loom is a silent, waiting beast, its hundreds of silk strings stretched taut before you. Now, the rhythm begins. The air, which was filled with the silence of intense concentration, will soon be filled with the steady, percussive music of the loom. This is the moment a collection of threads begins its transformation into a unified piece of cloth. Your tool for this part of the journey is the shuttle. It's a small, boat-shaped piece of wood, polished smooth from years of use. Tucked inside it is a bobbin wound with the weft thread, the thread that will run horizontally, interlacing with the vertical warp threads you so painstakingly set up. Your feet find the tread less on the floor. These are the levers that control the harnesses. You press down on one treadle. With a soft clatter of wood, one set of harnesses lifts, raising half of the warp threads. This creates a clean, tent-like opening in the wall of the shed. This is the path for your shuttle. With a practiced flick of your wrist, you send the shuttle flying through the shed. It glides smoothly from one side of the loom to the other, leaving a single weft thread in its wake. Click-clack. You catch it on the other side. Then, you reach for the beta, the heavy wooden frame that holds the reed. You pull it towards you forcefully. The reed's fine teeth drive the new weft threads snugly against the previously woven cloth. Thump. This is the action that creates the dense, solid fabric. Then you press the other treadle. The first harness lowers, and the second one rises, crossing the warp threads and locking the weft thread firmly in place. This creates a new shed, but this time the threads that were down are now up, and the ones that were up are now down. You throw the shuttle back through in the opposite direction. Click-clack. You beat the thread into place. Thump. This is the fundamental rhythm of weaving. Open the shed, throw the shuttle, beat the thread, change the shed, repeat. It's a 4-part dance that you perform over and over. Your hands and feet move in a coordinated, seamless flow. It's a full body activity. Your mind enters a state of flow, focused on the rhythm, on the growing edge of the cloth. Inch by inch, the fabric grows before your eyes, a solid plane of color emerging from the web of threads. The sound, tete, as described in the ancient ballad of Mulan, is not the sound of a cricket, as some might translate it, but the rhythmic click-clack and thump of the loom, the sound of a daughter weaving at her post. In the midst of this rhythmic work, an interesting unpractical hack weavers used was to size the warp threads. This means coating them with a thin layer of starch or glue made from rice minus water. For example, before weaving, the sizing had two purposes. It made the delicate silk threads stronger and more resistant to the friction and abrasion of the head-lessened reed. It also tamed any stray, fuzzy fibers, making for a cleaner shed and a smoother weave. After the cloth was finished, this sizing would be washed out, revealing the true softness of the silk. It was a temporary strengthening measure, a bit of chemical scaffolding to help during the construction process. You are currently weaving a simple tabby or plain weave, the most basic and strongest of all weaves. But even this simple act is part of a much larger, and still debated, history. Scholars of textile history argue passionately about the timeline of loom technology, while the basic principle of interlacing threads is ancient. The development of the treadle-operated harness loom was a monumental leap forward. It allowed a single weaver to control complex thread-lifting patterns with their feet, freeing their hands for the shuttle. When exactly did this innovation occur and where? Some evidence points to China in the centuries before the Han Dynasty. Others argue for a more parallel development in different regions. The horizontal treadle loom you are using is one of the most significant inventions in the history of technology, and its true origin story is still a matter of scholarly contention. As you weave, you watch for mistakes. A broken warp thread must be immediately mended. Tying it back together with a tiny, strong knot, a flaw in the weft, like a loop or a snag, must be correct. You are both the engine and the quality control inspector. The hours pass. The light in the room shifts. The only measure of time is the growing length of the shimmering cloth wound around the front beam. The steady click-clack thump is a comforting, productive sound. It's the sound of creation. It's the sound of value being woven from thin air, one thread at a time. The plain cloth is beautiful in its simplicity, but your skills and the remarkable loom before you are capable of so much more. The true magic of Chinese silk lies in its ability to contain not just color, but pictures, stories, and symbols. The plain colored silk rolling onto your cloth beam is a thing of beauty, a testament to pure color and texture, at the true pinnacle of the weaver's art. The craft that made Chinese silk a near minus mythical substance in the eyes of the world is the weaving of patterns. This is the creation of jinjing, or brocade fabric where the images are not printed or embroidered on top, but woven directly into its structure. To do this, you need a far more complex loom and a different level of skill. Let's imagine you are now seated at a draw loom, a much larger and more imposing machine. It's so tall, in fact, that there is a seat for an assistant, the draw minus boy, perched high above the warped threads. This loom is set up with an intricate system of additional harnesses and cords, a kind of mechanical memory that holds the pattern. Your job as the weaver is still to throw the shuttle and beat the web, but the pattern itself is controlled from above. The process is a slow, collaborative dance. For each row of the design, the draw minus boy, following a gridded minus out pattern chart, will pull on a specific sequence of cords. Each cord lifts a unique combination of warp threads, creating a complex shed that is no longer a simple up or down. You then pass your shuttle through. For the next row, the draw minus boy pulls a different set of cords, and you throw the shuttle again. It is an incredibly laborious process. Weaving a few inches of a complex brocade might take an entire day. You might be weaving a pattern of swirling clouds, a symbol of good fortune, or perhaps a repeating design of dragons and phoenixes, symbols of the emperor and empress. Each element of the design is created row by row, pixel by pixel, with colored weft threads. You might use multiple shuttles, each with a different color, to paint the picture. The back of the fabric will be a cat's cradle of floats, long threads that run unseen behind the main design, but the front will be a perfect, integrated image. You are not just a weaver, you are a programmer, inputting data one line at a time to create a complex visual output. One of the most mind-minus, bending and technically astonishing forms of this art is assignment. A weft minus faced compound twill, or even more complex, a damas, where the pattern is created by the contrast between a satin weave and a plain or twill weave of the same color. A white minus on minus white damask with a subtle pattern of bamboo leaves that only appears when the light hits. A just right is a statement of supreme elegance and technical mastery. The pattern is a ghost in the machine, visible only through the play of light on different weave structures. A quirky and little minus known secret of these master weavers was the use of pattern minus reading rhymes or chants. For a complex, repeating pattern, the sequence of chords the draw minus boy had to pull could be long and difficult to memorize. To aid their memory, they would often create a song or a rhythmic chant where the words corresponded to the pattern sequence. The draw minus boy would sing the pattern, ensuring they didn't miss a step. It was a form of oral, coded instruction, a mnemonic device that turned the complex pattern grid into a memorable piece of music. The rhythm of the chant would sync with the rhythm of the loom below, a perfect fusion of art, memory, and mechanics. The origin and evolution of these incredibly complex looms are a major focus of scholarly research and debate. The draw loom, or a similar device, seems to have been developed in China as early as the Han Dynasty, centuries before comparable technology appeared in the West. Historians and archaeologists pore over the few surviving textile fragments from this era, like those found at Moang, Dui, marveling at their complexity and trying to reverse minus engineer the technology that could have produced them. They argue about the transmission of this technology. How did these advanced weaving techniques eventually travel west along the Silk Road? Was it through the migration of weavers, the capture of artisans in battle, or the slow, piecemeal transfer of ideas? The loom you are operating is a piece of cutting minus edge, proprietary technology first time, and its design is a state secret. With painstaking slowness, the image on your cloth grows. A dragon's claw begins to take shape, then its sinuous body, each scale perfectly rendered in threads of gold against a crimson background. This fabric is no longer just a textile. It is a story, a symbol, a carrier of culture. It is a piece of art so valuable that its worth will be measured not by the yard, but by the inch. This is the silk that emperors will wear, that will be given as diplomatic gifts to foreign kings, and that will inspire awe and envy in all who see it. You are at the absolute apex of your craft, weaving magic from memory, skill, and thread. Finally, the last weft thread is thrown. The last row of the pattern is complete. With a special knife, you cut the finished cloth from the loom, a length of magnificent brocade, heavy with thread and vibrant with color, comes free. You unroll it on a long table, and the full splendor of your work is revealed. It's more than just cloth. In your hands, you hold a concentration of time, labor, and artistry. You hold a form of currency. In the world you inhabit, this bolt of silk is as good as gold, or perhaps even better. Grain can rot, and livestock can fall ill, but a bolt of high-quality silk, if kept dry and safe from pests, is a stable and portable store of wealth. Farmers might pay their taxes not in coins, but in bolts of plain silk. A soldier on the frontier might receive his salary in silk, which he can then trade for other goods. The government itself maintains massive storehouses of silk, using it as a strategic reserve to pay for military campaigns or to provide relief in times of famine. You hold the fabric up to the light, the threads of the dragon design, perhaps woven with silk wrapped in fine gold leaf, shimmer with an almost divine light. This piece is far too valuable for a commoner like you to ever wear. Its destiny is to be sold to a wealthy merchant, who will then transport it to the capital city. There, it will be tailored into a magnificent robe for a high-ranking court official, a visual manifestation of his power and status. The type of fabric, the colors used, and the symbols woven into it are all part of a strict visual language. In the imperial court, your clothing tells everyone exactly who you are. An official of a certain rank is permitted to wear certain colors and motifs. To wear something above your station would be a serious, even treasonous, offense. Your silk is a key component of this rigid social hierarchy. This use of textiles as a status symbol lead to some interesting and occasional abus, or some PTU laws throughout history. These were laws designed to regulate consumption and to prevent people from dressing above their station. For example, at certain times, merchants, despite being wealthy, were legally forbidden from wearing fine silk, as they were considered a lower social class than scholar-minus officials. These laws were often difficult to enforce, and wealthy commoners would find ways to flaunt their riches, perhaps by using luxurious silk for the inner linings of their clothes, where it couldn't be seen by disapproving officials. It was a silent, sartorial rebellion. The value of this silk extends far beyond the borders of the empire. It is the ultimate export, the product that will give the legendary Silk Road its name. Merchants will buy your silk, pack it carefully onto camels, and begin the long, perilous journey west. They will traverse treacherous mountains and searing deserts. By the time this bolt of silk reaches Persia, or Byzantium, or Rome, its value will have multiplied 100. It will be traded for horses, exotic spices, glassware, and gold. The Romans, in particular, were famously obsessed with Chinese silk, which they called siricum. They marveled at its softness and lightness, and Roman senators complained bitterly about the moral decay represented by these revealing, shimmering fabrics, and the immense drain of Roman gold eastward to pay for them. The exact economics of this long-distance trade is a subject of intense debate and speculation among historians. How were prices set? How did merchants manage the incredible risks of the journey? They puzzle over the exchange rates between goods. How many bolts of your plain silk was a strong warhorse from the steppes worth? How many bolts of this spectacular dragon brocade would it take to buy a lifetime's supply of frankincense from the Arabian Peninsula? These were not formal, state-controlled markets, but a complex network of personal relationships, haggling, and negotiated trust among merchants of different cultures and languages. The silk you are holding is the very first link in this immense, globe-spanning chain of commerce. You carefully fold the finished cloth. It is the culmination of an entire year's cycle, from the first tender mulberry leaf, through the patient nurturing of the worms, the delicate reeling of the thread, the alchemical dyeing, and the rhythmic labor of the loom. It is all embodied in this single, magnificent object. It is a product of your hands, but it is about to leave you and begin its own journey into the wider world. a silent ambassador of a secret and beautiful art. As you fold the precious brocade, you are acutely aware that you are not just handling a valuable commodity, but a state secret. The entire process you've just lived through, from the cultivation of the mulberry tree to the complex mechanics of the draw loom, is considered one of the most vital secrets of the empire. For centuries, the monopoly on silk production gave your civilization an unparalleled economic advantage, and the authorities went to extraordinary lengths to protect it. The laws surrounding circular were incredibly strict. Revealing the secrets of silk production to a foreigner was a crime punishable by death. Exporting silkworm eggs, cocoons, or even mulberry seeds was strictly forbidden. Guards at the borders and checkpoints along the trade routes were tasked with inspecting caravans, searching for any sign of industrial espionage. The knowledge you hold in your head and in your hands is considered a strategic national asset. This official policy of secrecy created a powerful mystique around silk in the outside world. For hundreds of years, people in the West had no idea where this magical fabric came from. The Roman writer Virgil famously, and incorrectly, guessed that it was a kind of fleece that was combed from the leaves of trees. Others believed it was grown in a special kind of soil or came from the sea. The complete mystery only added to its allure and its astronomical price. The empire was not just selling a product, it was selling magic. Of course, a secret this valuable could not be kept forever. The story of how the secret finally got out is a fascinating blend of legend, folklore, and historical detective work. One of the most famous stories involves a Chinese princess who was sent to marry the king of Khotan, a small but important kingdom in the oasis towns of Central Asia. The princess, unwilling to give up the luxury of silk in her new home, devised a clever plan. She hid silkworm eggs and mulberry seeds in her elaborate hairstyle or headdress, and, as a royal personage, was not subjected to a rigorous search at the border. She brought the secret to Khotan, which soon developed its own thriving silk industry, breaking the Chinese monopoly for the first time. Another legend, popular in the West, tells of two Nestorian monks who, in the 6th century, traveled to China at the behest of the Byzantine Emperor Justinian. They observed the entire process of silk production and managed to smuggle silkworm eggs out of the country by hiding them in the hollow centers of their bamboo walking staff. They brought the eggs back to Constantinople, where they were successfully cultivated, establishing a European silk industry and finally breaking the Asian monopoly. A much less glamorous, but perhaps more historically likely, explanation for the spread of this technology is simply the slow, inevitable leakage of knowledge through human migration and interaction. Over centuries, Chinese immigrants settled in neighboring regions, bringing their knowledge with them. Weavers and artisans were sometimes captured in border conflicts and forced to share their skills. Merchants and diplomats, despite the official ban, surely saw more than they were supposed to and carried crucial pieces of the puzzle back home. The debate among historians is not if the secret got out, but how and when. They analyze the different legends, trying to find a kernel of truth. The story of the Princess of Khotan, for example, is depicted in ancient murals found in the region, lending it some credibility. They trace the spread of circular westward, from China to Khotan, then to Persia, and finally to the Byzantine Empire, trying to map the timeline of this technological transfer. They argue about which was more important, smuggling the silkworm eggs themselves, or transmitting the complex knowledge of how to raise them and reel the silk. The eggs were useless without the know-how. The secret wasn't just a biological specimen. It was a complex system of knowledge that you have spent your whole life mastering. You, of course, know nothing of these future events. You only know the rules of your time. You know that the skills passed down to you by your mother are for you and your people alone. The beautiful cloth in your hands is a product of this carefully guarded world. It is a symbol of your culture's unique genius. The thought of it being replicated elsewhere is unimaginable. You finish folding the fabric, wrap it in a protective layer of plain cloth, and prepare it for its journey to the market. The secret is safe. For now, the final act of your journey with this piece of silk is to let it go. You, or another member of your family, will take the carefully wrapped bolts of fabric to a local market town. Here, the hum of life is different from the quiet rhythms of your village. The air is filled with the calls of vendors, the braying of donkeys, and the chatter of 100 different conversations. In a designated part of the market, you will meet the silk merchants. These are men whose entire lives are spent in the world of commerce. They have a keen eye for quality, running the fabric through their experienced fingers, holding it up to the light, judging the evenness of the weave and the richness of the color. A negotiation will take place, a quiet, respectful haggling over the price. Once a deal is struck, you will exchange your beautiful, tangible creation for something more abstract: coins, or perhaps a promissory note, or credit for other goods your family needs. And with that, your connection to the silk is severed. It now belongs to the merchant. He will pack it with other bolts of silk, loading it onto the back of a mule or a camel. It will become part of a larger caravan, joining a river of goods flowing out from the heart of the country towards the vast, unknown lands beyond the western frontier. Your bolt of silk, the one you witnessed from its inception as a tiny egg, now begins the most famous part of its story. It becomes a traveler on the Silk Road. It will journey for months, even years, across some of the most unforgiving landscapes on Earth. It will pass through the Hexai Corridor, a narrow gateway of oases flanked by mountains and deserts. It will stop at the legendary city of Danhuang, a vibrant hub of trade and religion, where its beauty might be admired by Buddhist monks and Sojidi and traders. It will continue west, its fate in the hands of the camel drivers and the caravan masters. It might brave the searing heat of the Taklamakan desert, skirting its edges from one precious oasis to the next. Kashgar, Samarkand, Bukhara, and these cosmopolitan cities, your silk might be traded, its ownership passing from a Chinese merchant to a Persian one. Its value increases with every mile it travels. From the great markets of Persia, it might continue its journey, heading towards the shores of the Mediterranean. It could be loaded onto a ship at a port like Antioch and sail across the sea to Constantinople, the glittering capital of the Byzantine Empire, or even to Rome itself. There, in a bustling Roman throne, a wealthy senator's wife might pay a fortune in gold for this bolt of cloth from the land of Seers, the fabric woven from a tree's fleece, having no concept of the little worm, the mulberry leaf, or the quiet, rhythmic life of the person who created it. The very name Silk Road is a modern invention, a term coined by a German geographer in the 19th century. The people who traveled it would not have known it by that name. To them, it was just the road to the west, a network of shifting, dangerous, and incredibly profitable trade routes. And while silk was the most famous commodity, it was far from the only one. Your bolt of silk would have traveled alongside spices, ceramics, and precious metals, in a vibrant exchange of not just goods, but also ideas, technologies, religions, and even diseases. Historians continue to debate the true nature and impact of this legendary network. They argue about which routes were most important and when they flourished. They debate the extent to which it was a conduit for culture. Did the Roman glass found in a Chinese tomb and the bolt of Chinese silk found in a Syrian one truly represent a deep cultural exchange, or were they just a thin trickle of elite luxury goods? The Silk Road was not a single, paved highway, but a messy, organic, and constantly evolving web of human interaction, and the full story of its social and cultural impact is still being written. You walk home from the market, the payment for your silk safely tucked away. The sun is setting, casting a warm glow over the mulberry groves. You don't think about Rome or Persia. You think about the coming winter, about having enough to feed your family, and about the small basket of prize cocoons you set aside, the ones that were allowed to live. In a quiet room, the moths have emerged, flossed their brief, flightless lives, mated, and laid their pinprick-sized eggs on fresh sheets of paper. The whole cycle, the entire, patient, miraculous process, is resting, waiting for you to wake it again next spring. The sounds of the market town begin to fade now, replaced by the familiar, gentle quiet of your own home. The long story of the silk is complete. From the first leaf to the final, distant row, the tension of the journey, the focus of the loom, the heat of the dye minus verts. All that can melt away now. You can feel the weight of that long year gently lifting from your shoulders. The world condenses back down to the simple feeling of the cool night, and the soft texture of your own blanket. The intricate patterns of the brocade dissolve into the simple, abstract patterns that dance behind your closed eyelids. The constant, rustling sound of the silkworms has long since faded, replaced now only by the soft, steady rhythm of your own breathing. Each breath is a quiet wave, washing away the day, carrying you further and further from the shore of wake-off. There is nothing left to do, nothing left to prepare. The work is done. The story is told. All that remains is the deep, restorative quiet of the night, the silent, empty loom waiting for the dreams that